solving linear equations, miscellaneous examples coming up back into action. Hey guys, today I will show you how to solve linear equations, and basically this is another episode in this sequel, and for the previous episode, the links will be down below and you could jump into this later. And I'm going to come up with the miscellaneous examples, with the miscellaneous equations, and keep in mind that all you need to do is just come up with the value of x that satisfies your equation, that makes your equation true, or that works for your equation, if you will. So, and the way you would do is basically you want to get your x alone on one side of your equation. You want to isolate your x. You want to get x equals a number. That basically is going to be your answer, is going to be your solution, as they say, for your linear equation. Look at the first one. Suppose you have been given something like this. Looks a little bit intimidating since that squares pop out at you, but don't worry, because basically it looks like a quadratic equation, but in reality it's not, because you will see later these square terms, they would eventually cancel each other out. Now, the way you would do, first of all, you want to square these terms. So you want to remove these parentheses and you want to raise this binomial. This is basically binomial because you have two terms added together on the left side and on the right side. So first thing to do is to remove these parentheses. You could simply take this x plus 3 and multiply it by itself, but if you are familiar with the formula, let's say a plus b squared, and it's the same thing as the first term, squared plus twice the product of a times b and plus b squared. So I personally do remember this formula, and every time when something like this comes up, I definitely use this formula because it's life-changing. So, and again, as I said before at this point, if you are not familiar, if you don't remember, if you are not sure how to use it, so you could simply take this x plus 3 and multiply by itself. It would take more time, but eventually you would come up with the same answer. Completely up to you. So it simply becomes x squared plus double twice 2 times x times 3 gives me 6x, and plus 9. 3 squared gives me 9. On the right side, you end up getting, similarly, this binomial I'm going to raise to the second power. So x squared plus 4x, since 2 times x times 2 gives me 4x, plus 2 squared, 4. And don't forget this 9 hanging around, sticking around. Now, as I told you before, something would cancel for sure. So this x squared and this x squared. Well, if something appears on the same thing, if the same thing appears on both sides of your equation, it's precisely the same thing, and it holds the same sign, so it's positive, like x squared and x squared. It definitely cancel each other out, so you could just cross it, delete it. Why? Because basically if you want to bring this x squared to the left side, so you want to subtract x squared, so x squared and x squared basically would cancel each other out, as I said. So whatever you have the same thing on both sides of your equation, with the same sign, that's important, because if you have different sign, it will not cancel. So x squared goes away, and magically your like seemingly looking quadratic equation, it's not a quadratic anymore. It became a linear equation. Surprise, surprise. Yeah, that's why it's a linear equation. Now, the way you would solve You want to collect your x terms on one side and your numbers, your constant on the other side. So this for x, you want to bring it to the left side. So you want to take the opposite, you want to do opposite. So you subtract 4x from both sides. 4x goes away, and you want, and also you basically 9 and 9. So the same constant, so the same number. So you could also delete them because it's the same. And you would be left with 6x minus 4x, that gives you 2x. Bring down equality sign. And on the right side, after all this cancellation process, you would be left with just 4. Yeah, looks much better. And finally, thankfully, the last step. So you want to get your x alone, you want to isolate your x. Whatever attach your x, in this case it's this 2, you divide through both sides of your equation. You divide by 2. So 2 goes away, disappeared, and you would be left with x equals 2. That's your final answer, that's your solution, that's your number that works for your equation. Integer is a neat, precise integer number. You could check it out by plugging it in back into your original equation and see if it checks and works out, and it will. Now, moving on. Suppose you have been given something like this and you need to solve it for x. So you have 3 different parentheses. So first thing to do is remove them. So remove any parentheses that appear in your equation. So open up the parentheses. It has to be done with very what I'm saying. It has to be done with exceeding care, since you have negative sign in front of the parentheses. Keep in mind that the sign in front of the term, the sign, has to be flipped. So flip the sign. So negative x plus 5. So this sign has to be flipped, has to be switched. Minus 4 plus x. Again, this sign has to be flipped, because basically you have kind of invisible one in front, and what you do technically, you take this negative one and you distribute, you multiply this negative one by both terms inside of your parentheses. So minus 1 times x becomes negative x, and negative 1 times negative 1 becomes positive. That's from where this positive comes from. And whatever you have on your right side, keep it for now. So it's this negative x plus 2. Now check to see if something can cancel, can simplify, combine like terms. In other words, negative x and plus x, they will cancel each other out. Gone. Bye-bye. Delete them. So you have constants. So 6 plus 5 minus 4. 5 minus 4 gives you 1, plus 6. You end up getting just 7, and you have this minus x. On the right side, you still have this negative x over 2. Now, you want to clear off this fraction at this point, so you want to rewrite it without any fractions. And the way you would do is just simply multiply by 2 both sides of your equation. So you want to multiply by 2 left hand side, and you want to multiply by 2 right hand side. So keep it balanced, because you don't want to change the overall value of your equation. So make sure you put the parentheses, because over here, because these 2 distributes and applies to both terms inside. 2 and 2 goes away, disappeared, and you would be left with just negative x. So at this point, remove the parentheses, open this up. So 2 times 7 gives you, so keep in mind that these two gets multiplied by both terms inside the parentheses. So 2 times 7 gives you 14, minus 2 times x gives you negative 2x, negative x. And finally, you want to bring, let's say, this negative 2x to the right side. So I want to avoid dealing with negatives because it's kind of headache, and I always try to get rid of this headache. So you don't want this unnecessary pain, no pain. So you want to bring these 2x to the right side. So by adding 2x to both sides. So you want to add 2x, you want to add 2x. And you end up getting 14 still remains on the left side. Keep equality sign. 2x goes away, disappeared. And 2x minus x, about 2x minus x gives you just x. So you got your x alone. That's basically your answer, and you could rewrite it in the reverse order. X equals 14, but no matter at this point, and that's your final solution. This is your root for that linear equation. And if you feel like this, you could check it out by plugging it in back into the original equation. Everywhere x appears in your equation. Alright, so I hope it has been helpful to you. Thank you very much for watching, and remember, keep training your brain. I know everyone hates maths, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't before, so you will not miss out my new videos. Is it 14? Yeah.